Now we're going to state and prove a theorem involving accumulation points. This theorem says that if x is any real number, any number on the real line, then x is an accumulation point of the rational numbers, and x is an accumulation point of r minus q, which is the irrational numbers. It's a rather simple proof. We will let capital N be a neighborhood of x. And by the definition of a neighborhood, there is an epsilon greater than 0, such that this epsilon neighborhood around x is completely contained in N. Okay, and all we're going to do then is to show that there's an infinite number of points of rational numbers in this set, for starters. Okay, since there exist infinitely many rational numbers between x minus epsilon and x plus epsilon, well, that means there exists, because of that, let me go down here, there exist infinitely many rational numbers in the neighborhood N. If we have infinitely many rational numbers in this interval, well, this interval is a subset of the original neighborhood N, and that essentially takes care of half of it. The other half is the irrational case, and I'm just going to say the proof for the irrationals is similar. And that's legitimate to write because it's nearly identical. All you need to do is change the word rational into irrational, and a couple of different characters changing, and the proof would be nearly identical. So one last question about this before I erase the board and continue. Can you name a finite set, that's a set with a finite number of elements, that has an accumulation point? And I hope you've said no, because none exists. How could you possibly have an infinite number of points in a neighborhood of a point if there aren't even an infinite number of points in your set? So the answer to that is no.